solving equations containing radicals. So now we get to the big kahuna, right? Which is, how do you solve equations with radicals in it? So notice that all of these have radicals, right? They all have radicals in it, and we need to solve for u. So as you know, how I like to do things is I like to do it step by step. So solving equations with radicals. It's going to be a 4-step process. So the first step, and hopefully these steps make sense so that you don't have to think so hard of trying to memorize it. The first step is to isolate one radical on one side of the equation by itself. Most of the time, step 1 is already done for you. So most of the time, the radical is already sitting by itself. You look at number 1, number 2, number 3. So however, number 4, you have a radical sitting there, but you have numbers next to it. So here, to get rid of -3, how do you get -3? You add it to the other side. You get rid of -3 by adding 3 to the other side. So the first step could be really simple, like just moving a number across, right? Did you have a question? Oh, sure. Number 5 as well. I have a radical. How do I make that radical sit all by itself? Subtract the 6 on both sides, right? So again, it shouldn't be rocket science. We're just getting the radical to sit by itself. Again, number 6, the radical, is it sitting by itself? Yes, it is, right? The radical is sitting by itself. You don't have to do anything to that. Number 7, there's one radical on each side of the equation. All good in the hood. You don't have to do anything. Number 8, I have 2 radicals on one side of the equation. What am I going to need to do? Right. Add one of the radicals to the other side. So that's all it is. Step 1 is just get one radical all by itself on one side of the equation. Is that okay? So step 1, most of the time, it's not much work. A few of the times you got to do some work. Step 2. Step 2 now is, just like when we're solving equations, we don't want ugly things in it. So step 2, normally if we have fractions, we want to get rid of fractions, right? Now if you have radicals, guess what we want to do? Get rid of fractions. Get rid of radicals. So you get rid of radicals. Does that sound familiar? Have we heard about getting rid of a radical before? Yeah, I see some nods. How do you get rid of a radical? What did we do before? You square it, or you multiply it by itself, right? We did that. We did that for the last 30 minutes. Get rid of radicals by multiplying it by itself if it's a monomial, if there's just only one radical there. And that's why we only want one radical sitting on one side so that we could get rid of that radical. So you get rid of radicals by, so the question is how? We did it. We square both sides of the equation. So how do we do that? So let's take a look at square root of 4x minus 31 plus 6 is equal to 5. So we mentioned the first step is to subtract 6 on both sides, right? We're going to subtract 6 on both sides. If I subtract 6 on both sides, this becomes 0. So I end up getting 4x minus 31 is equal to, what? Negative 1. Step 2 is now I want the radical to disappear. How do you get a radical to disappear? You square it or you multiply it by itself, right? So this, I'm going to square it because when you multiply this by itself, what do you end up getting? You get 4x minus 31, right? Just like what we had mentioned earlier, that no matter how pretty or ugly it is, if you have a square root of a happy face multiplied by square root of a happy face, it's just a happy face. So I was trying to prepare you guys for what we were going to see here. Square root of 4x minus 31 multiplied by square root of 4x minus 31, you just get 4x minus 31 without the square, without the radical. Okay? And whatever you do left side, you must see to the right side. Okay? So what's negative 1 squared? positive 1. Dun, dun, dun. No more radicals. Right? So doesn't that look so much more easier to solve? Step 3, so once you get rid of the radicals, now you solve it as you normally would, right? And you know how to solve equations now. You guys have been doing linear equations. So here, to get x sitting by itself, what do? Add 31 to both sides. That becomes a 0. I'm going to go through this quickly. 4x is equal to what? 32. What do we do next? Right, divide by the coefficient, which is 4. That becomes a 1. So we end up getting x is equal to 8. And we're like, whew, we're done. Not. There's step 4. What is step 4? Check. And before, I had said, check if you have time. It's optional. It's just to know for sure if you got the right answer or not. Now, this is, you must check. And the reason why you must check now, because there will be times where when you plug it back in, it will not work, even if you did the math correctly. Those solutions are called extraneous solutions. Be careful of extraneous. So the word extraneous has extra, right? So extraneous solutions means that those solutions actually don't work. They're extra. They actually don't work when you plug it in. So here you go. Let's go ahead and check it. Let's plug 8 back into this original equation. So I asked myself, okay, 4 times 8 minus 31 plus 6, does that equal to 5? And I hear you say, no, Daryl. Why not? What's 4 times 8?
32.
32 minus 31? Square root of 1? 1 plus 6? 7. It doesn't work. Right. So x is equal to 8 is not a solution for this problem. This is an extraneous solution. And since there's nothing else, you say that this answer is no real solution. And the reason why it says no real solution, because here it says x is a real number, it has to be real, is because later on in this class, we're going to learn about complex solutions or imaginary solutions. So this problem has some imaginary or complex solutions, but not real solutions. All right, so a really good question to also ask is, why are there extraneous solutions in math? Why is it that we go through all this process and it does not work? Because even though we have these step-by-step algebraic things, the higher that you get into math, you have to think of the big picture. And you have to think of what we call the domain of a solution, meaning what are the possible solutions and what are solutions that will not work. So here, when you have a radical sign, there are restrictions. So radical signs, so there are restrictions to radicals. So here I'm just explaining to you why we have extraneous solutions. Because restrictions, what are the restrictions? Inside a radical, so for an example, if I have 4, what's a simplified version of square root of 4? 2, right? And the reason why is because 2 times 2 gives us 4. What if I said the radical of negative 4? What two numbers multiplied together will give you negative 4?
Positive 2 and negative 2.
Right, positive 2 and negative 2 will give you negative 4, but the two numbers have to be a pair. Is it negative 2? No, right? Because a negative 2 times a negative 2 will give you a positive 4. So there are no such answers where if you have a negative inside your radical, that you'll have a solution, or at least not a real solution. You'll have an imaginary solution, which I keep foreshadowing that we'll get into. But right now, since we're dealing with the real numbers, there's no number that'll work for there. So therefore, whenever you're dealing with radicals, there are restrictions to it, meaning you can't have a negative inside a radical. So here, when we have a problem such as this, where we have square root of 4x minus 31, the minute I saw equals to negative 1, I already knew that this answer is no real solution. I didn't have to keep going on. because you can't have a square root equal to a negative number because it'll be no real solution. So already if I got to this point, I would have stopped, but I wanted to keep going with it so you guys could at least see the steps and to show you guys that even if you didn't see that, when you plug it back in, it doesn't work. But right away, whenever a square root equals to a negative number, you can automatically assume that there's no real solution because a square root will never equal to a negative number unless there's imaginary numbers involved.